Hello, I'm John Smith. I'm the CTO of LiveAction, and I'm going to be doing a demonstration. So this is the fun part of the actual talk where we actually can play with the tool. So I'll give you an in-depth demo of the system views, the flows, the QoS, routing, IPSLA, and LAN, and do some use cases using the tool. So I got to sit down for this portion of the demo. So let me get this here. Okay. So this is LiveAction. We're kind of running on a 1024/768 screen, so usually we run it on like a bigger screen. So you got to bear with me a little bit. So at the top level, these are routers and switches that we have in our offices that we're monitoring. So these are live, and you can kind of zoom in, zoom out. And what we do is we can auto-discover these devices, and when you add these devices, we'll actually audit the capabilities. So we'll know if Ceph is turned on, do you have NBAR already on, things of that sort. And we'll bring it in and we'll actually connect these things up. So these are the actual routers. So the bigger circles, the smaller circles are the actual interfaces. And you can tweak this all you want. You can add more interfaces, you can add more devices, you can move these things around. You can annotate various things. So it is a living Visio diagram of your network. So people really like this because it maps to the way they think. It makes it very easy. But one of the things we did was we overlaid NetFlow on top of this. So there's so many different flavors of NetFlow, and we can absorb all those. So whether it's straight V5, V9, flexible NetFlow, whether it's MediaNet, AVC, NCell, or wireless, or even if it's an unknown, we'll actually bring it in. And we can actually show it going across the network for you. And we've actually completed multiple IVTs with Cisco. So I think we were the first one on MediaNet and other technologies. So we work very, very closely as Cisco rolls out all these capabilities. And one of the things we can do is we can configure how do you get NetFlow going. So that's one of the first challenges. Like, yeah, I want to do AVC or MediaNet, but how do I actually configure that? So we actually can do that for you. So you can say, on 2921. I want to configure this for flexible NetFlow. And with AVC and MediaNet, it gets a little bit more complicated because you might have to define certain policies and service policies to do this. So if I wanted to enable video and application, I can actually see the commands to do that for you. So it is somewhat complicated to do that. But what we did was, we're from Spirent, we do testing, so we actually verify these in our labs to make sure that these set of templates work for you, and we'll get the information that you want. So you can see some of the monitoring and then the deployment of the policies, for example.
And then once it generates that, how does it push that out to the device? Is it SSH to the device to?
Yeah, so you have a choice of SSH or Telnet, whichever way you want to bring in your devices. So we'll do that for you. Oh yeah, on the monitoring, I mentioned we do SNMP, but we do SNMP V2 or V3 as well. So once we enable NetFlow, you'll get this type of view, and you can see it all the way from endpoint to endpoint. You can click on these flows, and we'll actually highlight all the way across the system. So if you have a lot of flows, it's going to be somewhat hard to see where everything is. So you can do things that are kind of interesting, like flow dot. Just show me things that are EF marked. So we'll go back to the back end, and it'll actually draw all the flows that are DSCP EF. So it's kind of like Google search, except the syntax is more like Wireshark. So you could do things like combinations of at site equal to San Francisco, for example. Pick off only the flows that are from my San Francisco site. And so we have quite a bit of syntax where I can go flow dot. And these are all the different IPFix and flexible NetFlow fields. So it runs the gamut, right, of what you can do. So
back when you selected that first flow and you could see it highlighted, is there a way that you can hide everything that's not highlighted?
Oh, yeah, sure. So let me do that. So we have capabilities to say, create display showing only these flows, and it only show that camera flow. makes it easy.
Right.
And then, we're aggregating these flows, right? So if I go flow, unmerge, you'll see all the flows. So it's really not single flows. It's really sessions or transactions that are happening.
A quick question, there's a Mac client, I assume, as well?
Oh, yeah, so, yes.
Good.
So we're working on it. So it's
He's the only person in the room who doesn't care. One person doesn't care.
No, actually, we work so closely with Cisco, and everybody at Cisco has Mac, so we actually put it in, so the next release will have the Mac support in there. Yeah. So you can see end-to-end what's going on. You can also delve into this particular device, and it shows you exactly how these flows are getting switched within the device, and all the way down to like your NO interface. What's going into your NO, what's going into your local route processor. So it's very, very detailed, and you'll spend hours just looking at this going, wow, I didn't know that's what's happening. So I had one guy where we installed this, and we showed him like NTP, it's coming out the wrong WAN interface. He was using the wrong NTP server. A good example here is like, so this updates every 10 seconds, so I paused this, but I can yank out BGP, for example. And is this going to the right provider? Are you peering with the right person? So I'm going to say, show only these flows. I can convert this endpoint to IP addresses, for example. So that's your BGP session. And I could say, flow, unmerge. You can see all the sessions there. So there's all these different ways you can slice and dice this information, which is pretty interesting.
How about MTU mismatch?
Yeah, we don't do MTU mismatch. We used to a long time ago. We used to actually have like an MTU tester. We would actually send information, but yeah, we kind of cut that out of the product. Okay. But yeah, this is not useful, right? Because I'm just showing you everything. But it has the power to show you everything, which is interesting. So here I'm looking at the endpoints as IP addresses, but like I mentioned, I can show it as applications. And the applications it's using like NBAR too, right? Or you can make custom applications, so it knows things like Skype. So it's pretty useful to know that. But having this back end, we have this capability to be a DVR. So when I hit playback, you can go back to any point in time and say, from this point in time, just play it. And it's kind of fun just watching this, but typically, people have like a voice over IP problem, and you can filter that. So you can say, show me that flows that are DSCP marked EF, for example, and just play that portion of it. But usually when there's a QoS or congestion problem, it's usually not that traffic that's the problem. It's usually the other traffic, which is usually web. So this will show you the combination of what other traffic might be running at the same time. But it's pretty cool. It's a DVR for your network. And it's hard to do this at the packet level, but at the flow level, you could do this. Let me just pause this guy. So on this table, we show you all the different, so any template that comes in will show you the actual fields. And for specific ones like, MediaNet, we'll show you specific information like, loss event, jitter, all the things related to video and voice that you want to use for debugging. For AVC, they spend a lot of effort on understanding like application delay versus network delay, retransmissions, number of sessions, for example. So we bring in all that information, probably overly so on this particular table, but we have reports that make it easier to see all this as well. And
you also do analysis with this data, so you've got a ton of data that you can look at and filter and sort and so on, but do you also say, and here's a problem we noticed and you could do this to fix it?
Yeah, we don't do that analytics. That's one of the things that we want to do in the future, because we have this big data, but we're not really using it to, I can imagine for like capacity planning, application analysis, security. It's like a wealth of information that we do real-time alerting to some extent. So like if you want us to look for a certain blacklisted IP address, we'll do that. For like threshold crossing alerts on like MediaNet values, we'll do that for you as well. But yeah, we don't do the deep analytics that I think is like really useful.
For the address alerting, can you take a feed for that, or is it hand configured? So say I have an updating real-time list of stuff that I want to know about if it shows up coming in or out of a network.
Right.
And is there a way that you can absorb that in some sort of a feed mechanism?
Not as a feed, but as a file we can bring in for alerting purposes. But not an active, like a REST API into like a system. Yeah, people have asked for that.
That would be useful.
Yeah.
So this is layer 3 stuff. It also does, you can see the layer 2 topology and what's the path that would be taken based on the spanning tree, correct?
Yeah, layer 2 NetFlow is a little bit harder, right? Because on the Catalyst, you have to get layer 2 NetFlow coming off of those. So typically, most people use it for layer 3 and for other purposes. Layer 2 is a little bit harder, especially like intra VLAN.
Yeah, I mean, I was looking at the Dr. NetFlow's presentation, and I think he showed how he was demonstrating the ability to see the layer 2 path as well.
Right. So to some extent, you could do that. But yeah, you have to have it set up for layer 2 NetFlow. Okay. Yeah. So
that's how it would get it. It would get it through the layer 2 NetFlow.
Yeah. So we've done it on like 4500s and 6500s, being able to show like over port channel and trunks the flow going across. Okay. Yeah. So so all these flows, you can slice it and dice it various ways. So let's say, for example, you want to see it by DSCP marking. So we can aggregate by DSCP. You can aggregate this by IP address, for example, and you can customize this any way you want. So it gives you like a feel for what's happening in your network. Other things we can do is, let me put this back to display filter.
So it doesn't, it can't do anything by like locating the MAC address on the switch ports?
Oh yeah, we can do that. Yeah, so on the layer 2 portion, I can show you when we get to that. You can actually redo the ARC MAC table polling.
And it can't use that information to determine the path?
You could, but I mean, it's just more work. So, I mean,
it's not visualized for you.
Yeah, so, NetFlow was really optimized somewhat for layer 3 and for layer 2, but it's really hard to like stitch these flows across those boundaries. Because sometimes, the NetFlow gives us information in the layer 2 dimension, and sometimes, they give us information in the layer 3 dimension. So tying those together is hard, and also different devices do it differently. Like a 4500 would do it different than a 6500. Mm-hmm. So it's actually a pretty tough problem. Okay, so we have the usual reports as well. So let me just drill down into reports. So if you want to break down what's going across this interface, you can go reports, show application. And so these are all the different applications. We can use MBAR2 to find out more information, but I can slice this in other dimensions. So I want to see this as, let's say, DSCP. So we can slice it that way. We can slice it in terms of like bidirectional flow.
I guess that means you're not getting layer 2 QoS data either, right? So you're not seeing COS?
Yeah, we can get layer 2 QoS as well. And I'll demonstrate that in the layer 2 tab. So, we sliced it in multiple ways, application, DSCP, bidirectional, but you can also drill down into this particular row and say, show me this in terms of like DSCP. So we can slice that guy. So that particular bidirectional flow had like these DSCP values. So, we have the usual reporting that all the other tools have, probably a little bit more, but all the different ones you can see on the left-hand side. So whether it's wireless, PFR, NCell, AVC, you support all the different types. But you can also create custom ones as well. So every field that you can imagine for IP fix and flexible NetFlow, you can create a report off of that. So whatever you guys want, you can create.
Get a lot of customers in the data center doing this with like FCOE deployments?
We don't get a whole lot of data center customers. We primarily hit like the WAN, campus, branch. Some of them that have private data centers do use it on some of their nexuses.
So how much, I guess the thing I'm trying to understand here is it seems like we've got a massive amount of data and analysis available, almost a bewildering amount of data, right? Which means from a do it by hand perspective, this could be a very dangerous way to spend an afternoon or 7. And so I guess where I'm trying to figure out is, do people tend to use this as a reactive tool? We hear there's a problem, we go and dig into something, or are they able to use it as proactive? I mean, we already said that there's no kind of smart analysis built in, so it's not, at least on some of the other stuff, it's not proactively notifying me, hey, something weird's going on here.
Right.
And I'm trying to figure out how it can be more of a beneficial tool, both for the proactive and a reactive sense.
Right.
And from what I heard, the proactive bit might be the QoS stuff, I see something, I configure it, or is it still I can tell you to go configure it, but but it's still a manual process, right?
Yeah, it is. But on the being proactive, we do have alerts so that as things get out of like your applications, whether it's like voice or video, the jitter or loss increases, we can actually alert you based off of thresholds. And also on like the applications, we can tell you as the client-side delay or server-side delay increases, we can actually warn you. So like basic alerting, we do have those capabilities. Just deeper analytics, like understanding, did this flow ever take this path before? Like I can't answer that question. Did we ever see this IP address before in this context? It's a little bit hard.
Well,
but basic alerting we do.
If you look at a lot of network performance tools, right, and you mentioned there's some reporting, so it may be something you're coming on to. Management, they want to see a dashboard. They want to see traffic lights, right? Most of us, at the very least, if we go in, a top-end report of good and bad stuff, so that there's something helping us focus on what's going on, right? Yeah,
so basic top 10 and like basic trending of alerts of your system, we have that. So at the system level, we can do that. And for each technology, like QoS, which ones are hogging up all the bandwidth from your class perspective, which application is taking up more of the bandwidth. And from the flow perspective, we can show you things like top applications, top voice problems, top application problems. So we have those basic capabilities. But yeah, I think we could do better in like trending and doing dynamic thresholding and things of that sort. So that's kind of what I think about in terms of like more advanced analytics that we want to be able to do.
Seeing outliers and trends is important, right? Because unfortunately, most of us don't have the time to just poke through data for an afternoon looking for something, right? I mean, unfortunately, almost all of us are in a situation where, if we're not acting reactively, we need something that is popping up and letting us know before the phone rings that something seems amiss, and so there's just too much. There's just enough to get lost in. It's all cool data, but I'm struggling to figure out how I use it.
And on top of that, not only figuring out how we use it, but we're talking about massive amounts of data here, and I don't care what type of database you put it in this. My SolarWinds, my Observium, all my management databases now are growing exponentially daily with that type of data. I start putting this data in there, and now there's an incredibly high cost of disk space in order to be managing this. So not only do I have to fight the technological management perspective, I'm now fighting the actual economic battle of keeping this data with no return on it.
And potentially performance too.
And a performance. So I'm struggling with these same issues and economics to it.
Right. So I think if you're really going to instrument for NetFlow, I mean, you're going to have a high performance solution. So if you're doing like 1,000 devices and you want to get pretty good visibility in terms of NetFlow, if you try to do it on any other solution, you're going to have to start getting into like clusters, and it's going to be a lot worse. But for us, we're kind of optimized to be able to handle this kind of load with limited amount of CPU and VM resources, for example. So if you want this kind of visibility, I think this is like a really good solution. And it is a lot of data, but it kind of depends on also how you set up these alerts. So if you want to know exactly when video, voice, or applications cross a threshold and only get alerted then, we can do that for you. And we can export that to syslog to other tools as well. But yeah, our customers, I think, use it in multiple ways. And one of them is real-time troubleshooting. Like they get a call and they said, Skype or WebEx or one of the collaboration tools is just not working. You just do flow.app, you go to Skype, you'll see that flow. You can do the media trace or media analysis across that and be able to troubleshoot it. But at the end of the day, if you really want to fix it, you could go back in this tool and actually do the quality of service aspect of it. And the second part is troubleshooting, but it's historical. Like that actual call happened yesterday. So we have all the raw data to actually do all the correlation for you, and you can go back and fix that. And the third aspect is actually doing the trending and capacity analysis. So at the high level, you can see these flows. You can observe what those actual patterns are. And you can go back at any point in time and see what this looks like. So it gives you like a sense of like, this is not normal because I'm seeing a ton of flows off of my WAN interface that I usually don't. But as you use the tool, you kind of get a sense of like what's really happening in your network. And one good example is, this guy had like a firewall and it was actually hairpinning. And he actually didn't realize it was hairpinning, and he looked at that tool and he started realizing. So there's definitely a point in time when you first install it that you're going to find out stuff about your network that you didn't know, and you're going to find out stuff you didn't want to know because it just shows you that level of detail. Like, I don't want to actually go fix that, but there it is.
You said that this display right here typically refreshes every 10 seconds or something?
This actually, you have to manually refresh because it's across the whole entire system, so it's a more heavier. But this, when you go into the device itself, it updates every 10 seconds. Yeah. So
does it do anything to highlight change on each refresh or anything like that?
No, not really. You just see it disappear. So typically, if you're debugging a certain problem, you're going to filter on a specific issue. So we have pretty good filtering. You could do the text-based filters, or we have also capabilities to set up your own filters, so match on protocol ranges, advanced things like MAC addresses and VLAN.
So this goes back to Josh's question. I may have missed it, but what are you doing for a back-end database? Is it proprietary, or are you?
Yeah, it's a proprietary time series database optimized for large-scale NetFlow and network data. So, if you're really doing like 1 million flows per second, it is going to take like a 20-node cluster, right, for doing Cassandra. But we could do it in 1 node. So it kind of depends on like what scale you want to do it to, too.
Now, there's a QoS configuration aspect to this product that we haven't talked about at all yet.
Oh, yeah. Right? I've only been on one tab, which is the flow tab.
Okay.
So I'm going to ask one more question before you jump onto that.
Yeah, sure.
Back to the storage side. So your product reminds me of a bunch of different products. We've got DAM, we've got Mars. Those two very much correlate to what you're doing, but combined structures. Right. Then I look at other products like Network General that actually are appliance-based, very much flow-based applications for large environments. All three of those are really expensive, and all three of those have dedicated storage components to it. Are you guys selling this as an appliance? Is this software? How is this done? Because if you're selling as an appliance and you've optimized your appliance with terabytes and terabytes and terabytes of storage, this is more palatable to me. If this has to rely on my enterprise storage, this still becomes a real problem for me on a storage perspective.
Right. So it's actually software. So,
okay, so it is relying on my back-end enterprise storage. Okay. So
you have to provide us with some type of back-end, preferably something that's fast, fiber channel over Ethernet. So it does go back to like how much and how fast that NetFlow is coming. So if I can imagine if you're doing this on the data center side, it's probably easy to do 10,000 flows on a switch. It's probably more like 100,000 to maybe like 1 million across your whole data center, depending on where you look at it, and depending on how many points, how many devices in your data center you look at. But, our focus currently is really more on the WAN campus branch. So not as bad, but on the WAN side, it does get quite a bit too. So like some of the educational that we work with, I mean, they have hundreds of thousands of students, right? It's just massive.
So you're speaking my language now. I work for a regional education network. And 1 million flows for us is it's kind of a drop in the bucket. So at what point is the tipping point for your product?
I think any high-scale NetFlow is, you should use our product. And when I say million flows, I'm talking million flows per second, which is a lot. Like a typical enterprise on the WAN edge, probably you might do 10,000 flows per second. So if you do it across all your campus, all your branches, it adds up quite a bit.
Well, I have 600 or so sites throughout the state.
You need our tool.
Yeah, we have, I want to say, 600,000 students. Right. Just K-12, then we have higher eds, and then we have all different organizations that connect to us. So that would become an issue. Right. I'm not particularly saying we hit 1 million flows all the time, but we could potentially tip your product over. Right. A really good example was iOS 7 dropped, and we quadrupled our traffic rates with iOS 7. So we would potentially knock over a solution like that at the same time.
You need an on-net Akamai cluster.
And we have Akamai clusters, and we still pegged every upstream that we have. So
I think it'll be interesting to try. And with our new architecture where we're splitting it out into nodes and agents, where we're distributing to every node the capability to do like 1 million flows per second, I think it wouldn't be a problem, but we should try it.
Okay.
And the back end is very, very scalable. It's not SQL, it's not NoSQL, it's optimized for that. But for the educational department, I mean, we work with certain colleges and universities. They do a lot of telepresence because they're in rural communities and they can't send a teacher out to every one of these schools. So they actually have Chinese taught at a main headquarter building, and then they actually do telepresence to all the different remote schools. And they rely a lot on like MediaNet to help troubleshoot that, and also the law firms, because they don't want to actually do negotiations in person because it's just too expensive. So they do telepresence-based negotiations. So one of the larger law firms use ours to actually debug that. But the QoS is really key because with telepresence, you can't drop a lot of packets, right? You have to have the right QoS, so they use our QoS aspect.
Now for your proprietary backend, do you have scaling metrics for given n number of flows per second and data retention of n days or weeks or whatever? How much data, how much storage the customer needs to provide, so that you can. I'm not asking for you to tell it now, but I mean, you guys have that available for somebody that's installing?
Oh yeah, definitely. Okay. We have that. So we have specs on what kind of servers, how many cores, how much memory, and things like that.
Yeah, I got a question. So this interface you're looking at here is just accessing the data that's on the back end somewhere else, right?
Right.
And you'll have a Mac app that'll do that soon.
Right.
Do you have a local install ability?
Oh yeah, you can. You can web start the application, or you can install it as a full Java application as well.
Because someone's asking from Twitter if it could be used, as like a portable app for network assessments. Like NetBrain CE, for example.
Right.
Is what they're using.
So you could install it locally on a PC or in a VM on your station, plug your station into the network, and do some limited amount of assessment off your workstation.
Yeah, you could. I think we do have like consultants that actually do that kind of model as well. So it's really good. Like when you first go into a network and you don't know what you're expecting, like this is a really good tool to like understand what's going on.
But presumably you've got to, like most management tools, you're going to have to give it a fair amount of access and configuration on the network devices in order to be able to pull that data off, right?
Oh, yeah.
So do you see an impact from, if you're getting every single flow without aggregation from NetFlow, do you have problems either with CPU utilization on the end platforms, or simply not running out of cache space on the platform before you're doing a NetFlow dump?
Right. So,
or am I misunderstanding NetFlow, which is very possible?
Yeah, you could. Like if you turn on, every single interface, every single sub interface on like a 6500 or like a Nexus, you could, I assume. But our tool makes it so that you can actually set NetFlow on specific interfaces, and you can do a sample NetFlow if you wanted to, and you can also filter out to like what specific type of traffic you want NetFlow off of as well. So you could be very granular in terms of like the NetFlow.
Unfortunately, sorry.
Oh no, I was just saying, can you set upper and lower bounds on I guess on your flows per port or device or whatever? So to Ed's point before, if you're experiencing a certain percentage utilization across all of your devices of NetFlow, and you see a massive spike because everybody's suddenly downloading the latest Apple whatever, right? And you get a fourfold increase. Is there a way to limit that so you've got an upper bound on what, so you don't crush your storage system unexpectedly?
NetFlow is kind of a push technology, so we absorb whatever comes in. We have capabilities to set, if you're hitting a certain amount of like disk usage, we can start purging if you wanted to. Okay, so let me just show a couple more things on the flow side, and then we can move on. So let me just filter on this particular iPad. So we're talking about education. There's always a lot of iPads in education now. So this is filtering flows going to this iPad, and I'm just going to look at this table, and I can look at information about MediaNet, for example. So packet loss, inter-arrival time. I can right-click on this and say, show me the path analysis for that particular set of flows, and we can gather that statistics. And this kind of shows you cross-layer information. So for example, this knows that these are the order in which this flow traversed. So it went through the 2921 first. The CPU utilization, the inbound interface, outbound interface, which QoS policy hit inbound and which it hit outbound. The orange means there's actually drops happening on the outbound policy here. The jitter is high and also the packet loss is high. And I can ask it, show me this path back on the topology. So if I show it back, it kind of pinpoints that, you got problems right here. I mean, the problems are starting from here and just inundating the path later on as well. But you can see that there is QoS issues happening because this orange on the bottom layer is saying egress drops happening. So I'm going to switch over to the QoS tab and take a look at this. So for QoS, at the high level, we can tell you drops. You can mouse over and tell you like policy. But I'm going to double click into this. And right off the bat, what we show you is going out this interface, what's trying to go out, and what's being allowed by that policy. And typically, I use a bigger screen so you can see all this information. But you can see that interactive video is actually getting dropped here. So you can see here. So, we do everything related to CBQoS. Whether it's hierarchical, we can actually parse all that statistics out. We can show you things like NBAR2 statistics right off the bat as well. So you can see Skype, Citrix, YouTube. So stateful application traffic with your QoS traffic as well. So to fix this, I could just go right-click, adjust output QoS. It'll actually read the QoS configuration on the device, and we're modeling in Java what's happening on that particular device. So interactive video, it's 1%. You probably need to give it more, so maybe like 10%. So you can do on-the-fly changes. And the reason why we made it so interactive is, back to that whole military stuff, right? I mean, you got to make changes. You got to make changes now. We let you do that. You can preview the CLI. But you'll notice that we put the no command in the right place because we know from the model that there's already a bandwidth. We have to take that out, put the new bandwidth in. So if you do complex policies, you can imagine the changes. It's really like a CCIE typing it in directly, right? And understanding what has to get removed, what has to be added, for example.
So it doesn't save the config when it's done?
You could do it. I could push this down.
No, I meant your preview there didn't have a write mem.
Well, yeah. So if I exit, it'll ask you if I want to do a write mem.
Oh, okay.
Yeah, so it only does the running config unless you ask it to. Yeah. I'm going to say no.
So if you were pushing config to 100 nodes to change something, you didn't want to have to go back and SSH all of them. No, that's cool. Okay.
So once we make the change, it'll fix itself. But let me just show you all the different capabilities. So we have a full MQC editor built in. So everything related to MQC we can do. So this will load up all the policies that's actually on that device. So that particular policy that we modified was a hierarchical policy that does high-level shaping at the top level, so it does 4 megabits, and at the bottom level, it does this egress policy marking. But a lot of our customers, what they do is from the headquarter building to all their branches, they might put separate bandwidth limits because at the branch, they're limited. So let me just create one real quick. So hit hardcore QoS. So this will be our top level policy. I'm going to create some classes. So let's say this is site A. I'm going to create another policy, site B. So at the top level, I'm going to shape both of these to like 10 megabit, for example. So 10 megabit on both. And then what you could do is you can reuse that policy, for example, this base egress. And I can just plop it down on site A, and I can plop it down on site B. So I kind of have like a 12-class model policy now going to 2 sites limited by the bandwidth that I'm going to be sending. So this is kind of good for your educational where you have multiple campuses and you want to limit based off of like the bandwidth restrictions. So it makes it a lot easier. But you control this using that one base policy at the lowest level. But I mean, doing that by hand is a bear, right? Hierarchical QoS policies, but you could preview some of the commands to do that. But we know everything about all these different policies and what to set up. So let me just go to that interactive video. So on the classify side, this is all the matches, but we know all the different matches. So these are all the different ways Cisco can match on policies. And HTTP using regular expressions, RTP. But the cool thing is NBAR2. With NBAR2, you have these application groups. So you could do categories, and instead of typing in all these individual browsing method, you can just say, I want everything related to this, and just add it. Or I could do things like gaming, just add it. So it's like a big time saver where it does categories of applications that you couldn't do before. And these applications, NBAR2 traffic, is the same thing you saw in that NBAR2 graph that I showed earlier. And it's also the same one that you see in Flow. So there's correlation happening between NetFlow and quality of service. So as you see applications, you can bring it back into the QoS aspect. And I forgot to show you, but you could right-click on flows and create an ACL, right? So when you do that, you can bring it back here and do match on ACL, for example. So there is a workflow into like understanding things, but also fixing things using the tool, which makes it very useful. So once you can set up the different classify, you can remark this if you want. You can set the queuing. You could do priority queue, for example. But it's smart in that it knows that you can't do shaping on priority queue. So we built in a lot of rules about what are the restrictions, and you can preview the CLI again, and it gets more and more complicated as you make the changes. And once you have a good policy, you can push this out to multiple devices, and it will actually know the configuration on each of the target devices, and it'll fix up that policy. So if you use an ACL, it'll bring the ACL over for you. If you define an NBAR, it'll bring that NBAR definition over for you. So it's pretty sophisticated in the QoS aspect of what you do.
So I'm looking at that list of devices that you had up there, just kind of embedded in the names, and you have several different platforms, Catalyst switching platforms, different routing platforms, not all of which implement MQC in the same way. And if you get into the Catalyst line especially, every chipset's a little different for the layer 2 functionality. So how do you cope with the different capabilities each platform has? Okay, so we cheat. And we cheat by doing MQC, because MQC is universal across CATs, but we don't do the layer 2 portion of, like you're asking about, the CAT 65 and 45s. So, I mean, over time, it's getting more MQC-ish. Like on the Nexus, you got like the QoS policy side, and you got the hardware queuing side. So as time goes on, we're hoping that it converts, because otherwise, we would be spending all our time doing hardware-based level queuing commands and translating that.
So that's probably what we spend all our time doing, right? That's what we're trying to avoid.
You're not doing the layer 2, like different line cards at 6500 might have different chips with different capabilities. You're not actually doing that level.
We can show you the QoS statistics, but we don't actually set up the hardware queues.
Okay, so as far as pushing policy, you're confined to MQC specifically.
Yeah. So I think low-hanging fruit for us is customers have asked, can you do auto-quas on the CAT switches? So we might do that, but the hardware queues are just too hard for us right now. And the other thing is, as these controllers come on board, and like the Nexus and other architectures come on board, it's going to get more and more abstracted. So I think us spending the time on like the CAT 65, and it's already getting replaced by the 6800s, it's probably not time well spent right now for us. Okay, so let me just go through some more of the QoS aspect of it. By the way, we fixed that interactive video, the drop stop, so that was good. And you can also look at very detailed statistics. So you can see before QoS, after QoS, exactly which match statement that traffic hit, for example. And you notice that adjust outbound, we fixed our drop problem there, so it stopped turning orange. And let me just go back to the high level. So we were asking about best practices. So we work with the Cisco team, and we built in a lot of capabilities in terms of like what are the basic QoS policies that you want to deploy. So we built into the tool things like 3 class, 5 class, 12 class. So you could go as complicated as a 12 class MediaNet or 12 class RFC 4594 policy. And we have it all set up for you, like some of the basic matches and a DSCP value. So it saves you a bunch of time. But if you're starting out, we have 3-level basic policies as well. So it depends on the sophistication of the enterprise where they want to start off with. And you might start off with like just monitoring, for example. So we have monitoring policy without any queues set up. And you can also set up a policy based off of NBAR monitoring. So we can monitor NBAR for you and start up, put it into various categories and start monitoring. So it's a good way to get started. But one of the main things to do once you start using the tool and want to start doing QoS is audit. So if you hit the audit button, we'll actually go and talk to every device in the system and give you this summary report. And it's actually pretty useful. So it tells you number of devices, how many policies it found, you know, are there drops, are there issues going on. At the system level, it'll tell you that this system contains 138 distinct class names, excessive. So we built in, you know, this is our test system, so we have excessive classes. But for each device, it'll tell you, you know, what kind of queuing it's set up, what kind of priority queues. Let me just show you some good. Okay, so here you were asking about the cat series. So it says enable QoS on switch will remark DSCP cost value to 0 by default. So you know, unless trust is enabled. So you might want to enable trust on this particular cat. So I mean, you see that a lot where people don't put on trust, and then everything is remarked to BE or cost 0, and you don't know why. And then we can show you, like, you know, performance metrics across all the different interfaces. A list of all the issues that it saw, and a list of all the policies and where it's applied to. So it just gives you like this big report of, you know, what's the state of QoS across your system. Very useful.
So, you know, that has the Catalyst 3560 on it. It's, I guess, quality of service is really important end to end.
Right.
And it's a little bit unclear to me where I am and what I'm looking at when we wouldn't have all the information we need from a Catalyst perspective in the tool.
Right. So, I mean, at least we can tell you some of the issues about, you know, where the policies might be applied and priority queues. But let me, on the layer 2 side, we can actually dig into like the 38s and the Cat 68, and we can show you in detail what the hardware queuing looks like. So we can show you that, but it's a lot of information at that point.
Okay.
You know? So that's a little bit on the QoS side. I'm going to dive into the routing side. So went through QoS, went through flow, and this is routing. So what this shows you is we take the routing tables and we grab it from all the interfaces and we visualize it. So all the different protocols that you see, we can actually show it to you. And you can ask specific destinations. So for example, use this as a destination. Show me all route table entries that will take me to this destination, and I'll show you across the system, show you what kind of route it is. So it's kind of useful. But we can also show you route adjacencies. So real-time adjacencies for OSPF, EIGRP, and ISIS. So you know, we have adjacencies that are being formed. And you can see it both together if you wanted to. But the interesting thing is next hop analysis. So I can ask it, you know, how do I get to this particular destination? And show me all the routes. So I'll ask every router, you know, from every subnet or every interface you know, how would you actually route to this particular subnet? So it's pretty interesting. And when you mouse over this particular route, it'll show you hop by hop which route table entry you'll actually take. And
now, is it pulling that data real time from the devices, or is it like periodically collecting the route table, and then when you do a query, is it looking at
so you have to
stored data?
Yeah, so we don't actually go out and query it. You actually ask us to refresh it, and we'll actually do that. So we don't periodically do it automatically. Okay. And you know, the best routing tool out there, in my opinion, is the packet design. Right? It acts as a passive router and it grabs all this information. But it's somewhat expensive. But you know, ours is kind of a poor man's Route Explorer. And the reason why I say that is, without having to be a router, a passive router, and gathering all this information, we grab it directly from the devices. And the good thing about that is, if there's routing problems on that device, we know. Whereas if you're an external router, you know less of it. You just know that these adjacencies may not be there. So one of the things we learned is early on is it's really, really hard to get this routing table. And we tried multiple ways. And if you try using SNMP, it actually might kill your router, because SNMP is such a process-intensive made to get route information. So the only way we figured out is actually doing the CLI. So we actually do a show IP route, we grab this information, we parse it, and we show it in this visual way. And that's the only way we found to be able to do this. And it's interesting, we've done this on, you know, internet edge routers with, you know, hundreds of thousands of BGP routes, and we can actually show you that. But it's actually pretty interesting.
Now, is the route collection also available looking back over time like the flows were? Or is this just a static? You know, because one of our things is, obviously, we've got a problem with something, and it'd be great to be able to go, oh, look, 30 minutes ago, a route changed.
Right.
Yeah, the path changed. and that's probably the cause of the problem if we can align it.
Yeah.
So is there that history with the routing like there was with the flows?
Only from like the adjacency point of view and like the routing status. So let me just show you this real quick. So from this point of view, like ERGRP, we can tell you like if the neighbor is there, if the adjacency is up or down. That we have reports and alerts off of. But the actual route table entries, yeah, we don't have the capability to say, go back to 2 days ago and show me what the route state looks like. It's something we can do, we could do in the future.
Selfishly, it's something that would be quite useful.
Right.
I don't know if you've seen like the BG Play tools,
right?
I mean, that kind of thing is phenomenally powerful to go back and go, what just happened? And you look and go, yeah, there it was. And you've got the data, you're grabbing it, presumably on a fairly regular basis. What an opportunity, right?
Well, I don't think he's grabbing that data on a regular basis.
But we should. We could do that, and we could do exactly like...
You're saying today it's manually refreshed.
Right. And part of the reason why is that we didn't focus too much on the routing. We kind of wanted to do enough because our customers... it's great if you have QoS and flow, but if you're screwed up routing, nothing works. So we kind of wanted at least some way to understand the routing layer. But we can spend more time and make it as good as like a packet design box, for example. But yeah, we just...
Well, so I mean, what we get a lot is when a problem comes in and people say something can't talk to this other device, right? You say, okay, give me a source and destination. You go look it up and you say, well, I can see where it goes. And then the question is, well, where should it go?
Right.
Where did it go yesterday?
Right.
I mean, I can tell you where it does go. I don't know if that's always, don't always know if that's right.
The problem with that approach is that you'd have to scrape the routing table. There's no way to signal that, right? So the BGP Play tool all is pulled out of route views data, which is, you create a peering with that, so it sees all that
same as the Route
churn.
Explorer concept, right?
Right. So if you could create a peering with this box, you could have all that data easily.
Right.
I'm not being funny, but grab it once a day and then let me do it on demand when there's a problem and compare. That's probably sufficient.
That would be useful. That would be useful.
Or even just allow me to take a grab before and after I make a change. How's that? Right? Allow me to do a manual and compare with the last manual grab I did.
Depends on the problem you're trying to solve.
Sure,
packet design needs to be able to, it can show you all those real-time changes and then play it back to you, so you can go back to a specific point in time and see, oh, I had a route flap happen here, which had an impact X.
Sure.
Which, on the other hand, doing what he's describing would be good for what you're talking about, before and after a change.
Well, I mean, because I appreciate you say saying it's a poor man's tool, like you said, is a bit unfair maybe, but yes, I'm just thinking like you can get an easy hit on a good feature there to at least be able to show diffs between two snapshots, right?
Right. So yeah, I'm hoping that in the future that some of this information will come through NetFlow actually, because it's a much easier way to like grab information.
With SFlow, it's fundamentally built to do those things, right? It's modular. You can run it on a host and export random host data off of it if you want to. I think so. SFlow may actually be a better option. Of course, you run into the problem that Cisco doesn't do it.
Right. So on the PFR side, they actually do tell us like when there's route changes happening, and we actually absorb that. So maybe over time they'll do it for just routing in general too.
So, but we could go back in time and see the path a packet took through the network.
So the cool thing about this is, as you make route changes, you could go back to flow and see if that flow actually changed, right? So that's the power of this tool is. You don't only see it from the routing perspective, you see it from all the different dimensions.
Sort of ascertain that data out of the flow data, right? Because if the flow is in this router and then it's not anymore, clearly something changed, and you can kind of go further down
deductive reasoning.
Because I think a lot of times what happens is people leave PBRs and ACLs around and they don't realize that what the effect of that is. So the ground truth is this flow. If you don't see that flow, then it's not there. Right? I'm just fixing this real quick.
You had mentioned earlier talking about port channels. If there's a port channel, can you figure out which specific channel, member of the port channel a flow took?
Oh yeah, you could. Yeah, you could. So I think we did that with one of the customers where they were doing like a 4500 to 45 and a 45 to 6500 connections. And if you set up the NetFlow, it's a little bit complicated, but you can see flows going across those port channels.
But I mean, individual member of the port channel. So say it's a four lines, it went across number 2.
I have to say, like, I think it depends. Is it a 45 or 65? Because they do it slightly differently, and sometimes they show you exactly which layer 2 port it flowing off of.
Well, if you had I guess if we had the hash algorithm, we could do it with the information that's...
Yeah, the information's in there. Yeah,
right.
You can pull it out of these boxes usually.
Actually, I have a white paper on that. So
Flow 9. Is that a field in Flow 9?
I don't know the field structure that well.
Yeah, I can send you a white paper on that. I think we have some examples of that. Let me just dig back into the routing real quick here. So you can dig down into this 2921 and we can show you the route table entry in this manner as well. You can filter whatever information you want. If you want to do it by VRFs, we can show you VRFs. If you're doing PBR, we have a full PBR editor, so you can edit it, set it up, and then you can observe on the flow side, what the effects of that were. So it has quite a bit of capabilities, even on the routing perspective. I'm going to switch over to the IPSLA portion. So IPSLA is actually really cool in terms of like being able to create synthetic traffic to create tests. Like I come from Spirent, and to do testing, you have to put this box out there. But with this, I can just go right-click, set up quick test, and we could put in DHCP, DNS, video. I can also right-click on the destination on the other interface. Actually set up a full IPSLA test and put the responder on the far end as well automatically, so you don't have to know any of the IPSLA commands to do all this stuff. But once you set this up, we can give you metrics off of latency, jitter. I mean, it's pretty detailed. So latency, jitter, packet loss, MOS score for those particular tests. So this is good for like pre-deployment, understanding if you can support voice, video, telepresence, for example, and during operational too. But yeah, so some of our customers, they use like shadow routers just for the purpose of like doing IPSLA testing. And the other feature that we have is large-scale IPSLA tests. So we can set up massive tests very easily. So if you want to do real-time or application tests, do that, set up a test. And then you can say, I want to do jitter, video test, I want to do telepresence, I want to do a hub and spoke, for example, bidirectional. And then bring in all the various devices, add devices. And then you can set various parameters, and it will actually generate the configs to do all the IPSLA tests, and we can actually push this out for you. So these are the different CLI commands it would take to actually do that. So if you have a large WAN deployment, like education is a good example, and you want to verify at midnight if you're gonna, if you have voice or video problem for tomorrow morning's classes, you could do that pretty easily. And there's other dashboards based off of IPSLA, so we can tell you overall health, warning, errors, what's the trend, for example, based off of IPSLA.
Can you consume RTCP reports for like voice flows?
No, you can't do that. It's either NetFlow or, it has to be NetFlow.
If I want to deploy a mesh of IPSLA operations, between like a wide area network with a cloud in the middle, can I deploy a mesh, say, do this operation between all of these routers?
Oh yeah, you could.
Yeah,
you could do that.
I don't have to build them out one at a time is what I'm saying.
Oh yeah, that wizard will actually do that for you. It'll know exactly what that other far end device is and make the correct config on that far end. And if there's a responder that needs to be set up, it'll set up the responder as well.
Yeah.
So with that in place, and with kind of all the other data you collect, can you actually set up tests based on triggered events? So something happens in a flow, you run an entire wide IPSLA test that you already have set up. Can you do any type of triggered event? Yeah,
we don't do triggered events yet, but that's one of the big pieces that's missing from our tool is like the more deeper analytics, like based off of the things that we know, do other things that are more useful. So we're definitely building those in. So I think we only have a couple more minutes, but let me do the LAN side. So LAN is kind of interesting where we're talking about port channels and trunks. And first thing we do is using CDP and LLDP, and also looking at the layer 2 MIBs, we can tell you exactly the port channel and which trunks it goes over. So we can make those associations. So you can see ether channel. You can click on particular VLANs and we'll show you which trunks it's going to take, which port channels it'll take. But you can also specify exactly which VLAN. So VLAN 10 is going to take VTP across these paths, across your layer 2. And if you're still doing spanning tree, we can show you root bridge, which one's forwarding, which one's blocking, right?
Oh, how lost.
That's what I was asking about her.
So, everyone's going through more VSS, layer 3 campus, but, there's still a lot of people that are doing spanning tree, and it's really hard for them, right? Doing the CLI to get this view is pretty difficult. So this tells you instantly what's the problem, and you can merge the two so you can see the VTP path with the forwarding and blocking at the same time.
Is it fair, if you have a virtual port channel or something, do you correctly see 2 uplinks to 2 chassis as both being in forwarding effectively, even though it's a single spanning tree port on one end?
I want to say yes.
So you don't tie into Nexus though, right?
We can bring in the Nexus, but we haven't really tested this. We're testing more with the Cat 6.5, 45s.
Right. Okay. Yeah, because what you were telling us earlier with the way that you get, or the example was a routing table where you pull the data from an SSH scraping session. Right. The routing table output for Nexus is entirely different.
Oh yeah.
You'd have to do that. So VPC is a Nexus specific feature, so I imagine you'd have to rewrite a few things to get to that point.
Yeah, we're getting more and more requests on the Nexus, so we're spending more time. So CBQS, tends to work on the 5K, 7K, so we'll be working on that. MQC works on the 7K, so we're working on that. But slowly, NetFlow works already. But yeah, slowly we're adding more capabilities. But on the Nexus, it's a little bit hard because it's in the data center, and with SDN and all these controllers, it's like, how does our tool fit with, if you have APIC or the ACI or those other tools? Not exactly sure how the fit would be.
With your VLAN visualization, is that relying on VTP status or having pruned VLANs, or is it? And having gone into data centers where every VLAN is spanned everywhere and there's no VTP, I'm wondering what would you see, or would I just see bleh? Which is how it feels where the traffic goes across, by the way.
We do it specifically to each VLAN, but I don't know the answer to that question.
Well, I mean, if I do a show VLAN on a show in trunk or something on a switch where I trunk every VLAN out of every port, right, you'll see every port listed.
Oh, yeah.
Right. I'm just wondering if there was anything more to it than that, like, the VLAN's not configured on this other end of the switch, right, so even though it's coming out of one end of the port, it's clearly going nowhere, that kind of thing.
Or if you're like me and you actually absolutely hate VTP and you put everything into passive, how does it report, that kind of stuff?
Done straight.
I guess we could show some of that, but at the detail level, we can show you for all the VLANs or particular VLANs, which trunks it uses and which access ports that are under it.
But what's the mechanism it's using to get that data?
I can't recall the exact MIB, but it's a SNMP MIB.
Oh, it's an SNMP. Yeah.
Okay. So when I originally looked into this, it seemed to me more like this wasn't a component of VTP; it was a component of spanning tree. And it was actually showing the only the active links for a VLAN for us from a spanning tree perspective.
I was thinking the same thing.
Because I looked at this before, and that's the way I interpreted the view that we were being presented, as opposed to it being something from VTP.
Yeah, the spanning tree is a different, I think a different MIB that we grabbed that from, and the VTP is probably a separate one as well. So it was actually a bit of work to get the spanning tree. It's actually difficult because it's on a per VLAN basis that you have to do that. Mm-hmm. But yeah, for more detailed questions, I think I have to talk to some of the engineers.
What about support for MPLS? Like, say I wanted to see how LSPs stitch throughout the infrastructure, or a pseudo wire or something.
Yeah, we don't really do that level. But if things like pseudo wire was projected through NetFlow or like multicast, for example, then we can show the actual data path of those type of traffic.
Okay.
So one of the things that we could do is we also find information based off of ARP and MAC tables that we pull. So you can ask it, where did you find a particular IP address? So it saw these IP addresses in the MAC ARP tables in these switches, and I can ask it, zoom to device, and it'll actually go find it. So I wanted to show that cool animation because we spent a lot of time on it. So this is kind of the end of the demo session, but I just want to summarize that. We started off with quality of service, right? Understanding congestion, fixing QoS, getting visibility into that. But we kind of realized you wanted to see the application level of how these traffic flowed across the system. But if you screwed up routing, it doesn't mean anything. So you wanted to see the routing perspective. But if the link quality is bad, you wanted to understand it as well, so from the IPSLA perspective. And then layer 2 is also another issue that people want visibility. So going back to that whole visualization, it's not just a single layer, and it's not just NetFlow. It's NetFlow, SNMP, CLI, show it in all the different dimensions so that you get a good understanding of the network. But once you get a good understanding and you see the problem, fixing it with QoS. We also do ACLs. We do other management. But in the future, it's going towards high-level abstractions and policies to help fix your networks.